Okay, so Assalamualaikum warahmatullahi taala wabarakatuh, and good day everyone. So today this is a recorded lecture for chapter 4. So it's a fourth chapter for this course, and we just completed chapter 3 in our last asynchronous lecture. So chapter 4 ni pasal random variables and process. Kalau you tengok, saya tak pastilah you biasa dengar tak nama chapter ni. So this chapter basically again dia ada calculation sikit. Tapi calculation dia ni probability. Okay, the most related topic that I can relate is about the probability and statistic yang you pernah belajar dulu. Might be you wondering, okay, how does it relate with the principle of communication system, benda-benda ni. Okay, kenapa kena perlu belajar lagi probability? Kalau you ingat dia Poisson, apa benda entah, random variables, okay, normal distribution and so on. We will have a look again in this chapter. But now I'm going to relate dulu, okay, why do we need to study about this in this course, okay? Principle of communication system. Alright, so by the way, this chapter I divide into two parts. Part 1, introduction, probability and random variables, whereas part 2 is about the distribution function. Okay, we will have that later on lah. Okay, so as introduction, okay, so sekarang ni saya nak explain dulu how does this chapter relate with the course. Okay, sebab back to chapter 1 at the definition of communication system kan, kita nak transmit data dari from one point, from the transmitter to the receiver, right? From transmitter to receiver. Okay, sorry. Okay, so how do we transmit data from transmitter to receiver? Okay, what have we learned in chapter okay, based on what we have learned in chapter 3, right? Okay, we need a carrier. Okay, we need a carrier signal to transfer the data from the transmitter to receiver. So ni signal tu punya characteristic is a random signals. Okay, apa maksud random signal ni? Okay, if we relate, okay, if we relate signals, okay, or carrier tu dengan jalan, atas jalan yang kenderaan yang kita lalu kan, kita nak pergi from one point to another point. I always use this analogy when I want to explain to you about the communication system, right? Okay, we want to go from one point to one point, we naik kereta. That kereta is a carrier. So jalan yang carrier lalu tu, kita dah ada jalan a dedicated path kan. Jalan tu memang lurus je, but dia berbeza dengan kita punya signal. Signal ni, dia pergerakan dia random. Okay, we do not know dia nak pusing kanan ke, nak pusing kiri ke. It depends on the situation masa dia lalu tu. Okay, so in that case, maksudnya kat sini, it's hard for us to predict the precise jalan yang dia nak lalu. Okay, so that's why it is mentioned here, random if it is not possible to predict its precise value. Okay, macam signal, that's why kadang-kadang signal tu kita dengar clear, kadang-kadang tak clear, kadang-kadang delay. Macam last week, right, kita nak buat online class kan, to make sure everyone goes into the room, it takes some time. Okay, someone is faster, someone is slower. Okay, so that is what mean by random. Though I said that, okay, 3 p.m. everyone has to be here, but I can't predict that everyone will be here will be 3 p.m. at that point. Okay, so how we are going to so meaning that it's a bit difficult for us, right? Okay, because to plan everything. Okay, so here comes the probability theory. Okay, based on the condition that we're facing and so on, then we may guess. Okay, we may guess, okay, the probability that, okay, maybe Ilyas will be the probability that Ilyas will be the fastest one, for example. Okay, so in that case, if Ilyas will be the fastest one, the probability is higher. Okay, sebab kenapa? Why I say Ilyas will be the fastest when we go to the meeting room, because he is now at the hostel. So the hostel network is very good. Tapi siapa yang terpaksa keluar tu? Saiful. Okay, where to submit assignment pun he has to curi orang punya wifi. Okay, so in that case I can make a probability that the the chance or Saiful will be on time will be maybe 2/10, the probability. So it depends on the situation that we have. Okay, so for example, kalau kita tengok gambar ni, okay, if you have a look at this building, we have a car. Okay, so this car is moving, right? And at the same time we have a radio here. Okay, so this radio ni, so bila so radio ni bila dia area of a radio, bila dia bergerak, then signal tu kan yang kena dengan radio apa semua, so dia kena ada transmitter. Kat sini receiver. Okay, dia punya tu adalah clock tower kat mana-mana nak dengar radio, for example. So dari situ signal tu dah lalu bangunan-bangunan tinggi ni, awak rasa dia boleh tembus ke? Tak boleh kan, dia will be reflected. Lepas tu ada setengah tu akan absorb. Okay, this is called as line of sight. Okay, apa maksud line of sight here? Line of sight ni maksudnya benda ni obstructed line of sight. So this obstructed line of sight kat sini. Okay, so this area ni kan, so this area will capture the signal from the radio where the transmitter is somewhere. So maknanya signal tu random, so they travel all the way nak reach the receiver ni. So as what I said just now, the obstructed line of sight path ni maknanya signal ni terhalang dengan bangunan-bangunan ni. The signal can't go through, okay, because of the brick apa semua dia become shield. Okay, dia terhalang lah. Okay, at one point kalau dia tengok pada permukaan tu juga, permukaan bangunan tu macam mana, katakan dia punya permukaan tu menyebabkan signal tu reflected back pun ada possibility juga. So because of all this incident, it will somehow delay the signal ataupun signal tu lost terus. Okay, so probability theory ni kita deals with the statistical characterization of random signals. Okay, so we go back to what have you learned before lah sekarang ni, which is about the probability. Ataupun masa sekolah dulu, saya rasa masa matrix punya ada belajar, maybe masa dekat first year degree tak ada lah kot okay, which is what keberangkalian. So this probability is a random experiment. Okay, experiment whose outcome cannot be predicted with certainty. Maknanya kita tak boleh nak agak precisely katakan it will sure happen. No, we can't say that. Again, macam sekarang ni lah, siapa sangka kan, okay, at the end of the day kita tak jumpa dah. Okay, I don't think we're gonna meet face to face till the end of the semester. So hidup ni pun itself we're full of probability. Okay, ada satu je yang sure in the event that we have in this life. Apa dia? Okay, kalau dalam kelas ni saya buat teka-teki dah. Tapi sebab this is recorded lecture, so I just give you the answer lah. Mati je lah. Okay, so meaning that in this life, the probability is equals to 1. Everyone confirm akan mati kan. Kalau nak kata everyone will kahwin ke ada anak ke, it's not sure yet. Alright, okay. Everything in life ni is full of bukan nak kata random, is a random ni maknanya kita uncertain about the proses tu berlaku bila-bila. It can be at any time. Tak juga macam you nak grad apa, we have a certain time. Tapi maknanya sekarang ni is unsure that it will certainly happen. Okay, so kalau you belajar probability last time pun kita ada benda ni lah. Okay, the set of all possible outcomes. Okay, and then okay, sample space here, and then a single sample point or set of sample point in the sample space as, okay, the probability. Okay, maksudnya sekarang ni, for example, katakanlah you all lah yang ada dalam ni. Okay, kalau 6 orang ada Khairuddin, Daniel, Haziq, Aiman, siapa lagi, Ilyas. Okay, so the probability that each of you will listen to my lecture kat sini. Okay, the probability is it sure that everyone will listen this lecture at a certain time. Okay, pukul 9, lecture kelas hari ni pukul 3. Pukul 3 sharp everyone will listen. Okay, what is the probability? Is it 3? Is it, I can say 1? No, I can't. Okay, so it depends on your network quality. Perhaps I can make a probability. Macam saya cakap tadi lah, yang meeting room apa semua tu. Okay, so two events are mutually exclusive if the occurrence of one event precludes the occurrence of the other event. Apa maksud mutually exclusive ni? Mutually exclusive ni maksudnya benda tu tak akan bertindan. Will never happen at the same time. Okay, maksudnya katakanlah hari ni you ada kelas pukul 3 dengan saya kan, sepatutnya synchronous class. Then tiba-tiba keluar another probability. What is the probability that you will attend another class, English class for example, at 3 o'clock? So that is what we call as mutually exclusive event. It will never happen at the same time. At 3 o'clock, you will attend my class and English class because these two class is impossible, dia akan redundant. Kecuali kes Haziq itulah yang ambil apa, pembangunan lestari. Okay, where purpose, walaupun sebenarnya tak boleh nak add, awak ambil juga, so it become bertindan kan. So this is so called as mutually exclusive event. Okay. Alright, so for this probability, kita ada dia punya property lah. Okay, so the probability measure P is a function that assign a non-negative value. Okay, ni semua is just a revision to all of you lah kan. Okay, where the nilai sesuatu event to occur, the probability of the event to occur may varies from 0 to 1. Okay, so if you certainly sure that it will never happen, then probability will become 0 kan. Kalau you are certainly sure that the probability will to happen, then the probability is equals to 1, and the total probability should be equals to 1. Alright, and then mention here we have two event A and B, a mutually exclusive event. Okay, then PA union with B is equals to PA plus PB. Okay, so saya rasa yang ni I don't have to explain much on this because this is what you have learned before. Okay, so PA bar maknanya dia complement. A bar ni adalah katakanlah probability awak datang kelas A, awak tak datang kelas is A bar. So if I say that the probability that you will come to class now, probability that you will come to the class in real, of course 0 lah, tak ada orang buat kelas kan. The probability that you join the class, for example, for the synchronous class is 3/10 for example. Okay, if PA is equals to 3/10, then PA bar indicates that you are not coming to the class is equals to, okay, if PA equals to 0.3, then PA bar will equals to 0.7. Okay, PA bar is equals to 0.7 because these two when you add up together will equals to 1. And then this A and A bar ni pun kita consider as mutually exclusive because it will never happen at the same time. Kita boleh kata probability awak datang dan tak datang ni, ada possibility awak datang dan tak datang. No. Okay, there's no such a way. So that is so called as mutually exclusive. Okay. Alright. Okay, so kita ada kat sini. Okay, so if PA union with B, okay, if PA union with B, then become PA plus PB minus PA intersect with B. Okay, and kalau A1, A2, A3 ni are mutually exclusive, maknanya dia tak ada yang bertembung atau bertindan, then we don't have to minus with PA intersect with B. Okay, so it's just PA1 plus PA2 plus PA3 until PAM will equals to 1. Okay, tapi kalau A and B ni, there's a possibility that will happen, then you have to minus with PA intercept B. So this PA intercept B is so called as the probability of the joint event. Okay.